Okay, yesterday we looked at the method of graphing linear equations or functions in order to find their point of intersection or the solution. Today we're going to look at the second way, and that is by substitution. Now, when you use the substitution method, you're either going to solve for x or y, and then you're going to plug that amount into the other equation. Okay, in the substitution method, you're going to have to try to pick and choose which method you're going to use. If you try to graph them and where the point intersects is not on the grid, I mean, it's not really nice, then you're probably going to want to choose another method, and you might want to choose substitution. Substitution is if you solve for one of the values. Let's say in this one, I know that y is equal to 2x plus 1. Wow, they've already got that set up. I could graph it. It might be easily graphed. But this one isn't so easily graphed, is it? But if you're going to choose the substitution method, we're going to plug in a value for y, because y in this one is already isolated. Now, I like to think of this as a basketball game. Okay, right now, y is in my game. Here's the game. 3x plus y equals negative 9. But y is coming out of the game. And instead of its place, we're going to put in the quantity 2x plus 1. Okay, so let's rewrite this. 3x is in the game, but who's coming out? Y is coming out. What's going in instead? The quantity 2x plus 1. Now, the reason I put it in parentheses is because if you were subtracting that quantity, you would have to distribute a negative. In this case, we're not, but just to note that that quantity is being plugged in for y equals negative 9. Do I need to distribute anything here? No, so I can just get rid of my parentheses and go ahead and combine like terms. So let's do that. Can we combine like terms? And you get 5x plus 1 equals negative 9. Okay, now what do I need to do to solve for x? Okay, subtract 1. And I get 5x is equal to negative 10. Divide by 5. X equals negative 2. Now, what am I looking for, by the way? What is the solution to a system? It's an ordered pair. It is an ordered pair. So what I have just done is I found the x-coordinate to my ordered pair. It's negative 2. Now, how do you think I'm going to find the y? Plug it in, plug it in. So I'm going to go plug this back into my original because y is already isolated. So now we do the plug-in part. I'm going to take y is equal to 2 times, and we know that x is going to be a negative 2, plus 1. Negative 4 plus 1 gives you y equals negative 3. So my solution to this system of equations are negative 2 and negative 3. Now, what does that mean? What's that solution tell you? That's where they're going to cross. You can think of it that way. Or if I put a negative 2 in for x and a negative 3 in for y, it would make it a true statement. It would also make this one a true statement. If I put a negative 2 in for x and a negative 3 in for y, it would make both of those true statements. Okay, just to kind of prove this to you, let's graph both of them. The first one, where do I put my y-intercept? It's already in slope-intercept form at 1. Okay, then what I use? My slope, up 2 over 1. Up 2 over 1. And yesterday, you all did a nice job of putting all those points there so you can kind of see where do they intersect. Okay, then the next one, let's go ahead and draw my line on that one. And remember, I asked you to kind of label them. This is y equals 2x plus 1. Okay, the other one, let's solve for y. So I need to move 3x over, and I end up with y equals negative 3x minus 9. Okay, I'm going to go through negative 9. Does my grid go that far? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it does. 0, Negative 9. Okay, then what else do I know? It's a negative 3, but now I can't go down any, so I'm going to go up 3 to the left 1. Up 3 to the left 1. Ooh, up 3 to the left 1. Up 3 to the left 1. And where do they intersect? Right. So see, this is just another way of doing the same thing that we did yesterday. It's just called a substitution method. And a lot of times graphing can kind of be very time consuming. Would you agree with that? This is negative 3x minus 9. Okay, so we can still find that the solution to this system, no matter if I use graphing or if I use the substitution method, is negative 2, negative 3. Okay, let's kind of review then. What are the steps of if you're going to use substitution? Isolate one of the variables. It doesn't necessarily have to be the y. It could be the x. If one's already isolated for you, I go with that one. Okay, then you're going to substitute in an amount for that isolated variable in the other equation. Solve for that variable, and then plug it in to find the coordinates for the opposite variable. Okay, let's try one. You're going to solve this one by substitution. And substitution is really easiest to use if already one variable is isolated, or one can be easily isolated. So as you look at these, is there one variable that kind of sticks out that, hey, you know what, I can get it by itself really easily? Which one is the x in the first one? Okay, so let's do that. I'm going to subtract 2 y's, and I get x is equal to negative 2y plus 6. Or you can have 6 plus 2y. Okay, then in the second one, who is going to come out of the game? X is coming out of the game. Just the x. Okay, just the x. So in place of x, what are you going to put? Right, and I need to put it in parentheses. So I'm going to have 3 times a negative 2y plus 6 minus 4y equals 28. Everybody else stays the same. Okay, you're just substituting in whoever it is that's going in for Mr. X. Okay, now use your rules of mathematics or algebra. What do I do next? Distribute, and what do I get? Negative 6y plus 18. Anyone? Minus 4y. Good. Equals 28. Now what can I do? I can go ahead and combine my like terms. They're on the same side, and what do you get? Good. Negative 10y plus 18 equals 28. Okay, so we're going to subtract 18 from both sides. And I have a negative 10y is equal to 10. Divide both sides by negative 10. Y equals negative 1. So in my ordered pair, my y coordinate is going to be negative 1. But how am I going to find the x coordinate? Plug it back in. So I have x is equal to negative 2 times, what's my y? Negative 1 plus 6. Okay, what's negative 2 times negative 1? 2 plus 6 is 8. So x is equal to 8. So my ordered pair is 8, negative 1. Now another way that this one works really well is, you know, when we're doing it by graphing, don't your numbers have to be pretty small? Because if they're not small, they're not going to fit on your grid very well. So substitution is one method that you can use when you start getting into larger numbers that you have on an ordered pair or on a quadrant grid. Any questions so far? Any other questions on substitution method?